Hello students, today we are in the new chapter number 3. It is Understanding Quadrilaterals. It is under Geometry. Okay, so we have to start from the very beginning. Today our discussion will be, so let us proceed. Here, this is a plane surface. For example, this board is a plane surface. A sheet of paper is a plane surface. Now here, if we consider number of points, if these points are joined, okay, here they are joined, what we get? We get a plane curve. Alright, a plane curve is of any plane curve. All plane curves are of 3 types. One is open curve. Okay, number 1 is open curve. Next is closed curve. Third one is simple closed curve. Alright, now if I write the definition, it will be very lengthy, so what I will do, I will make a table and I will give the example of all these 3. So let us make a table here. Okay, we made a table to show open curve, closed curve, simple closed curve. Okay, here what is open curve? A curve which does not intersect itself is an open curve, like this. This is open curve. This is also an open curve. Here you can retrace like this. Okay, from here if we start, these are open curve. Now here what is closed curve? A curve which intersects itself is called a closed curve. Suppose this is a closed curve, it intersect here. Okay, so this is a closed curve. This is also a closed curve. This is a closed curve, intersect somewhere. Then this is also a closed curve because intersect here, at a few points that intersect. This is a closed curve. Now what is a simple closed curve? A closed curve which passes through a given point only once. Okay, so here this is suppose this point, if we start this circle, drawing of this circle from here, if you complete it, it will intersect here only once. But here, if you draw this, you are getting this point once. If you draw this, you are getting this point once. So this figure is not a simple closed curve. This is a closed curve, but it is not simple because this point we get 2 times. Okay. Similarly here, okay, say if we complete this, you can draw like this. This is also an example of a simple closed curve. So these are the examples of open curve. These are the examples of closed curve. These are the examples of simple closed curve. Please write the definition of all these 3. Okay, after this, I think this is clear to you. After this, let us start about polygon. Okay student, we took the topic to discuss polygon. Okay, now a closed figure, a simple closed figure which has many sides. A simple closed curve made up of only line segments or line segments. A simple closed curve made up of only line segments is called a polygon. Okay, suppose this is a polygon. This is polygon. This is polygon. These are all simple closed curve. Okay, you see, this intersecting point we get only once. This, okay, all intersecting points we get once. So these are all simple closed curve. But this here they are not like this. This is not a polygon because this closed figure is not made up of line segments. Okay, but here, so this is not a polygon. These all are polygons because these simple closed curves are made up of the line segments. That's why this is a polygon. Okay, now let us see different polygons. Suppose here the least number of sides in a polygon is 3. This is called a triangle. Then 4 sides is called quadrilaterals. Then 5 sides, 6 sides, what are the respective name? Let us make a chart. Alright student, here we made a chart for the classification of polygons. This is the column for number of sides or vertices. This is the name of the polygon, and here the sample figure of that particular polygon. Here you see in the first column we have taken the number of sides or the number of vertices. Here always you try to make it clear that in a polygon number of sides and number of vertices will remain same. Suppose there are 3 vertices, so there will be 3 sides. The number of vertices is 4, so there will be 4 sides. Okay, so number of vertices, number of sides are same. So in the first figure, first polygon, number of sides is 3 and number of vertices is 3. The name of the corresponding polygon is triangle. Here it is the figure. There are 3 sides. You can check 1, 2, 3. I have marked with the red marker. The number of vertices 1, 2, 3. Then when the number of sides or vertices increases to 4, then the corresponding name of the polygon is quadrilateral. There are 4 sides. Number of sides is 5. It is called pentagon. There are 5 sides. This is sample figure. Always the figure may differ. Okay. So if there are 6 sides, the figure is called hexagon. This is the figure, sample figure. 7 sides or 7 vertices, heptagon. If 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. Like this we proceed. Alright, this is, please make it a note. And these are all the number of vertices, name of the polygon, and this is the sample figure. Okay students, please try to remember what is the corresponding name of the number of sides, this name of the polygon. Alright, next topic to discuss is about diagonal. All of you are familiar with diagonal. Then also let us try to discuss it. A diagonal is a line segment connecting to non-consecutive vertices of a polygon. Non-consecutive. So let me explain. Let us draw any polygon. This is a polygon. Okay. Now you see, these two are consecutive vertices. But this vertex and this vertex, they are not consecutive. So if you join them, you get a diagonal. Okay, dear student. And here, from here, if we join to this point, they are not non-consecutive. Its consecutive point is either this one or this one. If we join these, then you are not getting diagonal. You are getting a side of it. If you join this, you are not getting a diagonal. To get a diagonal, you have to join with the opposite vertex or any non-consecutive point. Now, here if we increase the number of sides of this polygon, what do we get? Suppose here if we get a figure like this, here the number of sides you see 1, 2, 3, 4, 5. Earlier it was 4, now it is 5. Now let us join all the diagonals from here. You see, from here we cannot join with this, we cannot join with it. Okay? From here, these two are non-consecutive. These two are also non-consecutive. We cannot join with it. Okay, now if we start from here, if we join, this is one diagonal, this is one more diagonal. Alright student? So from here, from this vertex, we cannot join with it, we cannot join it because we do not get diagonal. From here we can join with it, others are joined. From here all are joined. So in this way we can get the diagonals. Okay. Now inside the polygon, this is called the interior part of it. Outside is called exterior part. This is the interior part of the polygon. This is the exterior part of the polygon. Okay. Now after this, let us discuss about another two types of new topic is to discuss about convex polygon and concave polygon. Okay, so here if I draw a diagram, then you can guess what are these. Alright student, so here there are many examples. I will try to start with one example of each. If we join the diagonals always intersect inside the polygon, or in this type of polygon each angle should be less than 180 degree. Diagonals always reside inside the polygon, in this convex polygon. And in case of a concave polygon,
if you try to draw the diagonal, there are two properties. One property is that if you draw the diagonal one diagonal will reside outside the polygon. Suppose these two are non-consecutive vertices, so if we join them, you are getting a diagonal, but it resides outside. It resides outside the polygon. So this is one of the property. Another property is that at least one angle should be more than 180 degree. What do you think about this angle? This is more than 180 degree. Okay, here each angle is less than 180 degree in this type of polygon. Here one angle is more than 180 degree. So this is the basic difference between convex polygon and concave polygon. Alright, now let us discuss about regular and irregular polygon. Dear students, now we have taken to discuss regular and irregular polygon. In both the cases they are polygons, but what is the basic difference? Regular means here the sides are equal, here sides are not equal. Here the angles are equal, here also angles are not equal. So here two things are equal. All the sides are of same measurement, here sides are not of same measurement. All the angles are equal, all the angles are not equal. If I draw the figure, you can easily understand. Suppose if we draw an equilateral triangle, all the three sides are equal, each angle, the measure of each angle is 60 degree. Now here we can draw a square. You know that in a square all the sides are equal, okay, and each angle is 90 degree. You can see here all the sides, four sides are equal, each angle is 90, all the angles are equal, each angle is 90 degree. Now here, if we take a case of a rectangle, all the sides are not equal. Maybe all angles are equal, but one thing is failing here, all the sides are not equal. Okay, now here any scalene triangle, this is irregular polygon. Okay, this is irregular polygon. Why they are irregular? Because all the sides are not same. Okay, here all the sides are not same. So today we have discussed so many things. Please go through it. I will try to write everything in the assignment. Alright students, please read it and please complete the assignment. Thank you students.